Okay, I'm Johann, Tagle. My current position is I'm the DBA here. So we're using MySQL. We also have NoSQL in place, but right now I want to focus on dealing with MySQL. So as you know, Friendster started. Although we redesigned the whole site, it's been around for quite a while, and so we have a considerable database size. So, so I want to share a few experiences with managing Rails application with quite a big database. Not the biggest, but still. So I'll be talking about ensuring some data integrity, modifying an online production database, some optimizations you can do, and then about profiling your queries. Some of these are not Rails specific. Some of them actually apply to other RDBMS. But so let's just go through it. So ensuring data integrity. So by default, Rails uses, and when you use MySQL with Rails, you use the InnoDB storage engine. So don't veer away from it. So InnoDB storage engine enables us to have transactions. So you don't have to, which enables you can roll back from it and have atomic transactions. Okay, so stay with InnoDB unless you have a really good reason not to. Like maybe if you want to do a full text search, which requires MyISAM tables. So what you would do there is to just make your lookup table MyISAM. The rest should remain in the DB. So wait, Rails newbies. Yeah. Okay. Validation is already familiar with you. Okay. So you want to ensure data integrity on many levels. No? So when you you create your form, you have your JavaScript checks there already. But of course, that can be circumvented by doing a direct post. So you want data validations also. And then on the database side, you want to be consistent. Still be consistent. I mean, maybe somebody malicious, or maybe just somebody will just make a mistake while accessing the database and insert some data that might not be following the business rules you have in your model, like uniqueness. So if you have a uniqueness validation in your model, put a counterpart unique index on the table. Okay. And then belongs to, as much as possible, you have a corresponding foreign key. It happened before, not here, with some applications I managed. Suddenly, the Rails application will give an error because it cannot find the parent record because somebody modified directly on the database, and that database doesn't have a foreign key relationship. So put it there. Also, user input data like should be validated. So like string lengths, maximum values per number, and then the last line, SQL mode, strict all tables. By default, MySQL doesn't use that. What it means is if let's say you have a varchar, a string column that's just 20 characters maximum, you put in 30 characters, it will practically silently truncate the last 10. Okay? If you do it in MySQL prompt, it will show that you have a warning, and then you just do a show warning to see that. But it will still allow the record to be saved. Okay. Previously, there have been some troubleshooting to be done. That's quite hard to find if the cause is truncated data. Okay. So with strict all tables, it won't allow that. We'd rather have a quick error message than and be alerted about it than get accept the data and then have some trouble later on, which is hard to troubleshoot.
We've run in production a few times with that.
Yes.
Where, there's like this one user that has a problem, and we don't know where that comes from. And it takes a while to realize that the data for that user was truncated, right? Because no error is thrown. So you have to go really look at the data, and then maybe you realize that it's truncated.
There. So I think that's the lone slide about ensuring data integrity. So now we're a bit more exciting, modifying a production database. Okay. What happens in MySQL when you alter a table is actually creates a temporary copy of the table, modifies the temporary copy, adds the whatever column, or drops the column, and then it copies all the data, and then drop the original table, and then rename the copy to the original. Thus, a single alter table command in MySQL does that. So if you just do an alter table, add column, add this column, it does the all of that. Okay. So if you have in your Rails migrations, you have add column, add index, remove column. When you modify that data, each line there translates to an alter table command. So imagine on a big database, big table, a table with 10 million rows on one of our actual tables. We're talking of locking the table for more than 10 minutes. So more than 10 minutes to do all that, to do all those steps. So you have to have a maintenance period, downtime for that, because nobody can insert new data, update data on that table while that's going on. Okay. People can read, but they cannot do any modifications. So imagine a migration that has multiple add columns like that. So if it's going to be 10 minutes, it's 10 minutes for each one. So here at Friendster, we don't run migrations on production. We don't run breakDB migrate on production. What we have is we have break task that on the deployment machine, we make sure we run the migrations on the deployment machine, and then we have a rake task that compares the run migrations on the deployment machine and on production, and then it creates the SQLs needed to that needed to be run on the production database, as if you actually run the migration, and that includes inserting to schema migrations the version number. Okay. So that's what, I apply the rake task. And then, but still on that rake task, I'll show an example of that output of that rake task. There. So that's an example of an output of the rake task. We just so that you can just copy paste the SQL to the production database. That's. But if there are multiple add column to a certain table, you have multiple outer tables. So what we do. It disappeared.
Alt-tab.
It's random. There. So what we do is to merge. So here you have 3 outer table X. You can combine them to one outer table, then add XYZ and comma the next modification, and then the next modification. So that this will just take one 10-minute run, if it's just going to be 10 minutes. But for large tables, we still don't do it that way. For small tables, go ahead. It's just going to take a second or so. So what we do is, for large tables, we simulate MySQL's outer table via, so you create a table like that one. So in here, XYZ new is still an empty table that has exactly the same structure as XYZ. And then you alter table, the new table for the modifications. Then we create triggers to copy updates from XYZ to XYZ new. And then batch copy the records in XYZ to the new one using the replace command. And then during cutover, do a rename. Rename the old table to the new one, and then to something, a backup table, and then the new one to the new old table. The rename can be done in one line again, and it's an atomic transaction. It won't affect. It won't be seen by any application or user. So to be able to do all these, actually, there's an online available open source solution from Percona, online schema change, which actually I discovered after I made my own script. Okay. So, but I still prefer my own script because it's mine. No. The thing with the Percona change is I haven't really tried it, but it looks like it does everything in one go. So, but we prefer to be able to do the last step on our own time, the actual renaming of the table. Maybe, I mean, what if that thing concerns a new column or a column to be dropped? So you want to be able to do the actual renaming when the code that handles that has been deployed. Okay. So, but go ahead. The Percona toolkit has many options, but right now I'll be showing a little about the script I made because it's in Ruby. That's why. So the way I do this is Ruby alter table, and then the table name, there, consoles, and then like add new column int, for example. Okay. So what it does is looks for if that table actually exists in the database, and then it looks for the current structure of that table, and then creates 2 files which you can run to be able to simulate make the online change. So let's take a look at the first one. So please see modify account info, so that's good. So just does a sanity check. What are the existing columns? If you want to check first, then it runs a file. Yeah, it created for you the SQLs you need to run to create the new table and then alter the table. Okay, And then here are the commands needed to create a trigger. Okay. So we have to create an insert trigger for each. So that's why it reads the current structure to be able to know what columns it has to handle to insert to. And then it creates an update, which uses the MySQL replace command. Replace is basically something, has practically the same syntax as insert, except that if it sees what you're inserting is duplicate of a primary key of an existing, it does the replace. It replaces that one, that row. So that works for the update, and then of course the trigger for delete. Okay. So given that you've run that, everything's still online. When I run this on a busy table, in a few seconds there's already new records in the account info's new. Okay. But then you still haven't copied the existing data. It only gets new inserts, new modifications. Okay. So what happens? So you have to go to the other one, the other file it created. It's in. So this one uses the SQL gem to copy the the rows over. It does it in batches. That's why you're able to do it without really affecting users' online transactions. So just loops, gets them min ID, max ID of the existing table, and then does the copying every 1,000. This is actually configurable, the batch size. There. After copying, after that, running that one, the last thing it tells you here is, during cutover, you can do this rename command. So rename account infos to account infos old, and then account infos new to account infos.
So both renames are atomic, right?
Yeah, that's atomic. Yeah. So there. So it's on my GitHub if you want to play around with it. Okay. Sorry. So okay, optimizations. So like with any database, you have to choose the right data type. Specifically, choose the smallest one that will do the job. If your values are only 1 to 10, use a tiny integer. Okay. If you're looking for just first name, I don't think. I think the default string varchar 255 is overkill. Okay. So why should we bother with this? I mean, there's a lot of people asking. Varchar 255 is good. I mean, can handle small ones and big ones. The thing is, when you put the data to storage, using varchar, you just use the number of bytes you actually use. Like Johann would just be 6 bytes. But when you cache data into memory, and then or maybe if you do temporary sorting, what's being used by MySQL is the fully defined length, maximum length of the column. Okay. So instead of caching just the six characters for Johann on memory, it's the 255. Okay. Also, for index fields, yeah, MySQL caches frequently uses indexes and even sometimes tables on memory, and it uses the whole defined what defined in the column definition. So it's really important for index fields. So again, please don't settle for the default string varchar 255. It's very rare anyway that you're imagining a form field that it should be 255.
So that includes the joining of two tables. It's incorporating temporary tables.
Yes, specifically for temporary tables, because that's one important thing. When you put temporary tables, MySQL tries to put it first in memory, but there's a limit to what it can put in memory. If it doesn't fit in memory, it will put it to disk, which is very slow. The temporary table. Okay. And again, the temporary table will use the whole varchar 255. If you define it, that's 255. So again, yeah, so put a limit and in your migrations. Think before using big integer. Do you really need big integer? The standard integer has maximum value of 2 billion, a little more than 2 billion. If you need a little more than 2 billion, maybe it's still maybe less than 4 billion, an unsigned integer will do. It still has the same number of bytes usage versus integer and unsigned integer. The unsigned integer just has the lowest value of 0 instead of negative 2 billion. Okay. Think before using text. Okay. Previously in MySQL version 3 something, varchar was just up to 255. That's why many people anything after 255 you use text. Okay. But now, take note that text columns, along with other large objects like the blob, are stored separately from the main row and require more overhead to read and write. Okay. Varchar now has a theoretical maximum of 64 kilobytes, although that's also the maximum size of a table row. So just take note, there were some on our cases like a message typed by the user. It had a maximum of 1,000 characters in the validation, but it was still put to text. So, and then the table itself didn't have much other columns, so we converted it to varchar 1000. Okay. Things like that, along with the string, resizing the strings to the real world usage, gave us quite considerable performance boost. Okay. So something to take note. So some other notes, when you say limit nn, varchar nn is number of characters. It's not the number of bytes. Okay. So you can have a varchar 255 that has actually the stored value is almost 1,000. It depends on the MySQL version, because on the next bullet, before version 5.5.3, MySQL only supports up to 3 byte characters. There are certain characters we've encountered, like there was this party icon that was a 4 byte character. If somebody puts there, we'll get an error before my 5.5.3. Okay. So there. Here, consider storing IP addresses as unsigned integer. Okay. So because an IP addresses before IP version 4, you need at least about 15 bytes. Unsigned integer is just 4 bytes. Okay. So you can use MySQL function to convert to integer and then to convert back. That's how you can do fast integer lookups. Because if you look at this query here, you're just doing, after the conversion by the function, you're just doing an integer comparison, which is the fastest comparison in databases. Okay, now this last part, it's really more for DBAs like me. But it's something that should be done in any web application. You need to profile. Okay. First, pay attention to the MySQL software log. By default, it's set to log something there if the query takes more than 2 seconds. Of course, by the way, by default, it's also not turned on, so you have to turn it on. Okay. So the threshold is configurable. As a matter of fact, I set it to 0 if I want to profile all queries. You can also, you use a slow query log to log all profiles for queries for profiling. What we do is, set it to 0, log everything for about an hour. That usually translates to 50 gig log file. And then there's a MySQL slow query log parser that parses all of those and then gives you a summary data. The thing I don't like about that one is, it just gives you how many times it was run, how many times, and then its average. Complete profiling, it's better if you know how many times it was actually run for under half a second versus how many times it actually run longer than that. One time we encountered a query, new relic alerted us something that looks so simple took more than 2 seconds. So why? So what we did is to run the whole profiling thing, and then found out, okay, it did that once, but 99% of the time it was less than 10 milliseconds. So nothing to worry about. So just a bit about the profiling thing. Now, this is online table. So this is my page. So, query profiler. Just to give you an idea, this is what you will see in a slow query log. So all that data. So good luck reading that. So we have the query profiler is actually a Perl script, okay, which I modified because what it does really is just to give an output to standard output, or redirect it to a file, just a summary. What I modified it so that it will put the profiling data to a database, which you can mine later on. So here's what I do. So I use along in that file something to create the tables to log the statistics to, and then set the long query time to 0 to temporary log all queries, and then run the query profiler. So it's Perl query profiler, something like that. And I changed this already so that I could upload this to GitHub. So I did not what do you call this?
Set some of the variables.
Yeah, change the database connection parameters already. But just to give you an idea, so what it does now is to upload it to 2 tables on my parser database. So it has this queries and query statistics. The queries that contains the actual text of the query, and the query statistics is for every time that query was run, how long did it take, how many rows did it actually touch, and then I run this thing, this profiling SQL, which I also uploaded there. Let's see. Okay, my PHP admin will complain that I'm already logged out. So that's quite a long SQL actually. Profile queries. Okay. I already have all there. So I'm profiling it to what grouping, how many ran for less than a millisecond, and all the way to more than 2 seconds. So the output is something like this. So this is the query text, how many times it was run, total of the times it was run, gives you how much actually SQL time, database time the query takes in total, and then how many times it was run. So this is actually a very bad query because every time all of them ran for more than 2 seconds. So I use that for every now and then, every time we deploy something major, profile all the queries, and then see if something needs indexes or something needs to be totally restructured. Okay. There. So, thank you. This last slide is just gives you some reference. The last 2 is about database instance tuning. So that's really DBA work, but it's something that your DBA should look at to really make sure, because the MySQL default instance, default installation, the performance is really crap. It's made for a single user. Okay, so really have to do some tuning. So that's it. Thank you.
Okay.